Hi guys, today in this video we will discuss about concurrent hash map. This is one of the most important interview questions that you can face in any interview. So we are going to cover following topics in this video. We'll discuss about what is map. Also we'll see about the concurrent hash map, their internal workings, and few the terms that is very important to know. And then at the last we will see concurrent hash map versus hash table and versus hash map. Okay, and we will also do some coding, and I will try to make it easy for you to understand what's the difference between these three maps. And I feel like after having this lesson, you will be able to understand the real difference between these maps. Okay, so let's proceed. So map is nothing, it's just a way to store data in memory. So when I say way to store, okay, so let's think you are in library. Okay, so you have seen there are lots of books, maybe thousands of books available in the library. So whenever you go to a librarian and ask to issue a book, he or she knows that where that book is kept. Why? Because they have stored them in a proper way so that the search of that book would be easy. What if we just keep books randomly? So in that case it will be very time taking task to find a book and issue that book. So you can understand like how important it is to store your data in a proper way. We can say that the structure matters here, how you are going to store. Based on your structure, the performance of your operations will be decided. So here we are talking about map. So now it would be clear, right? Map is a way to store data in memory. And how we store this data? We store this data in the form of key value. So for example, you can see here we have key and value. So as key we have these names, and as value we have these places. Okay, so we discussed about what is map. Now here I have added a very simple code to show you how to create a map. So here map is an interface, and I have taken an implementation of a map, that is hash map, and I have added few key value pair. That's fine. Let's move to the next slide. Now what is concurrent hash map? Let's read this definition first. Concurrent hash map is an implementation of map interface. So we know that, right? We have a java.util.map, and that map interface has multiple implementations. So concurrent hash map is one of the implementation of that map interface. And where we use this is useful in case of multi-threaded applications, where we have concurrent threads which is going to write in the map. And this concurrent hash map is thread safe implementation of map, and it is optimized in comparison with hash table. Okay, we'll discuss about that, about the hash table now. So here you can see, right, we have map interface which is extended by concurrent map, and then we have concurrent navigable map, and concurrent hash map has implemented concurrent navigable map. So indirectly it has the implementation of all the maps, right? Yeah, so this is about, and we can find this concurrent hash map inside Java util concurrent package. Let's see about the internal working of concurrent hash map. I'm assuming that you have knowledge about the internal working of hash map. So if you have that knowledge, then it's better. If not, so please go and read about the internal working of hash map. It will help you to understand this concurrent hash map implementation. So now we have hash table and we have concurrent hash map. Both the implementation of map interface provides the same feature, but there is a slight difference on the optimization perspective. Hash table is not optimized and does not perform well in case of concurrent users, whereas concurrent hash map is optimized and perform very well in the case of concurrent users. How it works? So let's see. In hash table, all the methods of hash table are synchronized. So due to this override of synchronization, the performance suffers. Whereas in concurrent hash map, instead of taking lock of entire map, it takes lock on the particular section that need to be marked as safe, or we can say, right, in a hash table, when we are marking all the method as synchronized, it means that if we have two threads T1 and T2, then if T1 is working on the map on the hash table, T2 has to wait until it finishes its job. Once T1 finishes its job, then after T2 will be allowed to work on the map. But in case of concurrent hash map, at a time, if there are two threads T1 and T2, and if T1 is going to read and T2 is going to write on the map, then the respective section of the map will be logged, and other section will be exposed for other threads, so that concurrent threads will be allowed to work on those sections. So what I'm trying to say here we have it is defined as segments, and each segment has hash map. So whenever suppose we have 3 threads and thread 1 want to update a value at index 0, so what happens, the lock is acquired only on segment 0 instead of entire map. Similarly, if thread 2 wants to put or update a data at index 4, then only the specific segment will be logged. Other segments like 1, 2 and 3 and others will be remain available for concurrent threads. I hope it's clear. So let me repeat. If there are multiple threads and few threads want to write and few other threads want to read, both can do their job simultaneously on the same map. When the threads which are going to write, they will first acquire the lock on particular segment of the map, and then they will perform their job. And threads which are going to read, they can read from any segment without any restriction. So that is how concurrent hash map improves the performance of this map. Okay, so that's it about the internal working of concurrent hash map. I hope you guys understand this. Let's go to next slide. Okay, so there are few things that we need to understand about concurrent hash map. The first thing, how to create a concurrent hash map. So there are constructors without any values. There are default constructors and there are parameterized constructors. So default constructors internally call parameterized constructors with default values. So let me tell you, with parameterized value, and then we will understand how it works internally. you can see here I have created a map, concurrent hash map, by providing 3 values. The first one is initial capacity, load factor, and concurrency label. So what is initial capacity? So initial capacity defines the map which we are going to create should be able to entertain that much amount of data. Let's say I'm saying that initial capacity should be 100. It means that whenever we are going to create the map, that map can at most have 100 entries in the map. Okay, that's the initial capacity. Now load factor. So what is load factor? When we define a load factor, for example, I have defined 0.9f. It means that whenever my map is filled 90%, create a new map and put this, create a new bigger map and put this data, means the old map data, into the new map. So that is load factor. Then we have concurrency level. Concurrency level says how many concurrent threads can access the map. Here I have defined 10. So it means that at most 10 concurrent threads can write into the map at a time. So that it defines the concurrent number of threads. Okay, so we discussed about initial capacity, we discussed about load factor and concurrency level. What's next? Next is segment array size. So whatever the segment we discussed, right, the internal architecture, here we have a segments. So what would be the size of the segments? The size of the segment should be always greater than the concurrency, greater than or equal to the concurrency level. That's why this is the formula. So 2 into the x, that should be the x, and that should be like greater than or equal to concurrency level. Guys, this is incorrect. Please consider this as x. So you have a number which should be greater than or equal to concurrency level. Then we have internal hash map. So sorry for this typo. So we have an internal hash map. Let me correct this. Hence hash map, and this should be x, a number. Fine. Okay, internal hash map. Now, okay, let's move to the next slide. Okay, so now we are going to see about concurrent hash map versus hash table versus hash map. So the first thing that we need to consider when we are seeing the difference between these map implementations, like which are thread safe. So a hash map is not thread safe implementation, so we cannot use in multi-threaded environment. Hash table, yes, this is thread safe, but it is not optimized. And concurrent hash map is thread safe as well as optimized, that's why faster than hash table. If we talk about the null values, so null key is allowed in hash map but not null values. Only null key, single null key is allowed. Okay, but in hash table null key not allowed but null values allowed. And concurrent hash map, neither null key nor null value is allowed. Okay, and if we talk about the iterator, we have hash map where we have fail fast. It means once you have created a iterator and you are going to iterate through that iterator, and while iterating you are trying to modify the map or modify the collection. In that case, what happened? We get concurrent modification exception error. So that is called fail fast. If you are trying to modify a map once we have the iterator created. Okay, now hash table and concurrent hash map are not, fail fast. These are fail safe. You can modify the map while iterating the iterating through iterator. Okay, fine. So let's move next. Fine. So we discussed a lot about this. We discussed about what is concurrent hash map, what are the key terms. We also saw differences. We also saw the calculation of the segment size and hash map size. Now let's look into the code and understand how we can create a hash map. Okay. So without delay, let's get into IntelliJ. Okay, so here I have created a class for demo where I have a main method. I have created a map of a string and of type string and integer, and I have created a concurrent hash map. So let me just give you a walkthrough with this class, and then I will show you a demo. So what I'm trying to do here, I have two writer thread and 10 reader threads. Okay, so when we are going with hash map, when we are using hash map, it means that there is no synchronization, there is no locking, nothing. So in that case, hash map implementation would be fast. So see, you can see here I have a writer thread. What it does, whatever the map I have created here, this will be the shared resource. That map I am passing it here while creating a thread instance. I have extended the writer class with thread class, and I have overridden the run method. So here what I have done, I'm going to run it from 0 to 10 million. I guess this is 10 million, right? It's 1 million. Okay, 0 to 1 million times. Fine. And now, and then after I'm printing this, how much time it took to complete this process. So this is my writer thread. As I said, we will create two threads which will write into the concurrent hash map or map. And then we have a reader thread. What it does, it just read data from map. Okay, so now let's see. So I hope it's clear, and I am using executors framework just to create a thread pool and submit this task, execute this task through executor framework. So guys, I hope you understand this. If not, please go and check what is executors framework. It will definitely help you to understand this code. So in simple words, I have created 12 threads. Out of 12 threads, 2 threads are going to write into the map, and here I'm going to make it like, I'm going to use 5 reader thread just for better visibility. Or okay, let's say I have set 10, so let's say 10. So out of 12, 2 threads are writer thread, 10 threads are reader thread. Okay, so now let's run this. Fine. So here you can see we have reader threads which is taking 370 milliseconds. So these are reader threads, and at the bottom you can find there are 2 writer threads. So writer threads are taking 606 milliseconds. So now let me rerun again. Remember, I'm using hash map. This is the hash map implementation. let me just, okay, that's fine. Let me rerun again. Okay, so you can see that it took time. One more time. Okay, so you can see that this is the range, right? 300 to 400, 500 to 800 the writers are taking. So you can understand the the range, how much time it will take. So this is the hash map. Let's go with hash table. So before executing the hash table, I want to remind you, we discussed about that hash table has all the methods synchronized. Even get method is also synchronized. It means that at a time only one thread can read data from the map. Okay, so that's why we have 10 threads and it is going to take time. So let me run this. Now you can see it is taking around 300 to 400 milliseconds in reading data. But when I'm proceeding with hash table, let's see how much time it takes. Okay, can you see how much time it is taking? From 300 millisecond it reaches 3406 millisecond, around 3000 to 4000 between 3000 to 4000 milliseconds, right? So almost 10 times performance impacted. So if we use hash map, it will run within 300 milliseconds. Readers will read data from 300 milliseconds. Let me rerun with hash map. See, now it comes in 300 to 600, right? Now again let's go to hash table. So you can see how much time it is taking. So I mean, it's not under 1000, it's taking more than 2000, right? More than 2000 or 3000. So it means that performance is getting impacted. Fine. Now then why not we are using hash map? So we just now learned hash map is not thread safe. So in a multi-threaded environment we cannot go with hash map, because if multiple threads will access will access the map concurrently, in that case there will be no data consistency. So that's why we cannot go with hash map. So now we have two options, hash table and concurrent hash map. So now we saw how the hash table is performing. Let's switch to concurrent hash map. Okay, so before executing this program, I want to again remind you or notify you, whatever you say. We discussed about the concurrent hash map. What is the benefit of concurrent hash map? Concurrent hash map does not provide log on entire map. It takes or it keeps log only on particular section where it is going to update the data. Okay, so right now we have two writer threads. So where are those writer threads? Here are two writer threads. So we have two writer threads. These two writer threads will acquire log on the specific segment, not the entire map. And the reader threads will be free to access any segment without impacting each other. So means there is no restrictions for reader threads, only restrictions for writer thread, and that on only specific to a particular segment, not on entire map. So in this case what will happen, by the time writer thread is writing into the map, reader threads will perform its job. So definitely if they will work simultaneously, it will take less time. So you can, let me run this, then I can tell you. Can you see? After using concurrent hash map, let me run one more time. One more time. Okay, so you can see, right, almost hash map and concurrent hash map, now they are performing, very well. But we cannot use hash map because hash map is not thread shaped. Concurrent hash map is taking little bit more time than hash map because there is, concurrent, there is locking mechanism involved, which takes lock and release locks after the work done. So that's why concurrent hash map is making this, execution faster. So here is the learning. Whenever we have a scenario where we are going to, there are multiple threads and those threads are going to read or write, and out of those threads there will be, more read, less write. So in that case, this concurrent hash map will be very useful. It will, it will not impact your performance. It will make your application faster, because it is allowing concurrent users to read from the map. I'm repeating the same thing again. Concurrent hash map allows reader thread, means threads which are going to read data from the map without restricting them, so that they can work simultaneously. If there are 1,000 threads and they are going to read, they can read from map simultaneously. But if there are threads which are going to update or write data into the map, concurrent hash map, then they have to, acquire lock for the particular segment, and that is taken care by the concurrent hash map implementation. So this is all about concurrent hash map. I will make another video about, the methods which are very useful there. When you are learning for concurrent hash map, like we have compute, if absent, compute if present, where you can use by function to pass values if the values are available or not. If the key is available, if compute if absent, if the key is not available, then it will, what it does, it insert the key with the value. So we will discuss in another video. But regarding concurrent hash map, that's all. Thank you so much for watching my video. If you like this, please hit the like button